nange eri ntandise the reasoning yo gyabadde nnyo
Yes, good morning, students. Welcome to Sumi Secondary School Physics Department, specifically our continuation and end of our study of current electricity. This is going to be our last lesson. Previously, we talked about applications of electrical heating. How is the heating effect used to our advantage? Now, we earlier said, whenever a wire is carrying current, it causes a heating effect. And how is the heating effect generated? We are saying that when you connect this wire to a source, the electric field between the ends of the battery accelerates the electrons to pass through the wire. And once they're accelerated, they gain kinetic energy. The kinetic energy so gained makes these electrons to collide with metal atoms. Once they collide with metal atoms, they give away some of their kinetic energy to the metal atoms. So the metal atoms are set into vibration, colliding with each other, causing friction between themselves and, in the end, create a heating effect. Now, the heating effect, how is it important to us? It is used in electric kettles, it is used in electric flat iron, it's used in cookers, and electric bars and tubes also produce that heat, although it is unnecessary. Now let's talk about one application at a time. We previously talked about this filament lamp, but we can talk about it again. When I talk about the filament lamp, I mean these ordinary bulbs. Now the ordinary bulb, if you look at the diagram which you have in your notes, it is composed of a filament, which is a coiled filament made of tungsten. It is also having a bulb. Inside it, there is an inert gas, argon or neon, and then we have lead wires that are connecting to the connected to the source or the holder. Now, how does it work? We are saying that the filament is made of tungsten, which dissipates, meaning that gives out light when current enters it. And the filament is extremely very hot, that gives out both heat and light. We said it is filled with an inert gas at reduced pressure. The purpose of that inert gas is to prevent evaporation of tungsten. And it increases operating temperature of the bulb. If that is not done, the vapor will condense and therefore blacken the bulb. So we are saying the efficiency of the bulb is improved by using coiled filaments. These coiled filaments, because assuming it was just a long filament, to occupy a large volume, so they are coiled to use a smaller space. And then in the end it reduces rate of heat loss by convection. Now, limitations or disadvantages of this filament lamp, and that is the reason why the government phased out filament lamps and started giving out energy saver lamps for free in order to reduce on the following. One, they are inefficient since most of the electrical energy is converted into heat energy. Because the essence of putting up these filament lamps is to provide light. But when you touch them, you really feel that they are hot. So the energy is converted to useless form of energy. Two, they are uneconomical to use, obviously, because most of the heat is lost, and therefore, and we paid for it. Lastly, they do not last for long. They do not last for long, since there is great dispersion of energy, and therefore the coil easily wears out. So that is in as far as the filament lamp is concerned. Now, two, a fluorescent tube. These ordinary long tubes. We are saying it is made of glass, coated inside with a fluorescent powder. Usually the fluorescent powder can be zinc sulfide and others. Containing mercury vapor. How does it work? Very simple. When it is switched on, the mercury vapor emits ultraviolet radiations. These ultraviolet radiations strike the powder. And when they strike the powder glows. Not glows, glows. Yeah? Glows means giving out what? Light without burning. So the color of light emitted depends on the color of the powder. If you want white, use white powder. If you want blue, use blue powder. If you want purple, use purple powder. So that is in as far as the then we got advantages of fluorescent tubes over filament lamps. Advantages of the tubes over filament lamps. One, the tubes are more efficient, cheaper to run. You're going to say, why are you saying cheaper, yet they are more expensive than the bulb? Yes, because they are going to be durable. They are going to last for long. So if you paid, for example, the cost of the tube is 10,000, I'll give you an example, and the other one is 4,000 or 3,000. You, at the end of the day, you may buy around 10 bulbs before buying one tube. Are you getting it? So in the end, it becomes cheaper, durable, and easier. Two, they do not produce unnecessary heat. Usually, they produce very little heat because they don't use the filament. It is just ultraviolet radiation that are striking the powder. Three, they are more economical to use, consume less electricity. And you are saying, the reason why you are saying they are more efficient, they give out brighter light compared to the bulb. Three, energy savers. Energy savers. You are going to realize that the energy savers are not any different from the fluorescent tube. They use the same principle. Are you getting it? But however, we are saying they differ in size and shape. They save energy in most of the electrical energy. Most of the electrical energy is converted into light energy, so there is no loss in form of what? Heat energy. The energy savers are more efficient in the sense that for them they are smaller in size, therefore more cheaper compared to the tube. But the principle they use is the same as the fluorescent tube. Then the last electrical heating is flat iron and the kettle. Flat iron and what? And kettle. The flat iron and the kettle contain a heating element, usually made of nickel. You know a heating element? Yeah? This coiled thing in a kettle. Even a flat iron, inside it there is a heating element, which is a coiled tube. Now the heating element is made of nickel. Nickel is a combination of nickel and chromium metals. Nickel wire is used because it does not oxidize when it becomes red hot. The purpose of making it coiled is to increase the surface area and distribute the heat easily. So that is as far as the heating elements, heating is concerned. Now we go to domestic electricity supply. We talked about it like the other previous time, and we started with safety devices. Among the safety devices we began with was the fuse. If I may ask my neighbor here, what is the role of the fuse? What does the fuse do?
To prevent short circuit.
So he said a fuse is a short length of a thin wire of low melting point which breaks the circuit when current through it exceeds a safe value. Or you can also say it is a protective resistor which melts when there is excessive current flow. Or you can say that it is a resistor that breaks the circuit in case of overloading or short circuit. I get you. But does not apply even if there is no short circuit. Current can come in large amounts, so it melts, and therefore ensure that the circuit is broken, and therefore the current cannot burn the appliances. 2. Circuit breaker, we said, disconnects the main current when there is accidental earthing of the live wire. 3. Earth wire. We said the earth wire conducts leaking charge, preventing electric shock. It is usually connected to the casing of the metal. If it is a flat iron, connect the earth wire to the casing. The casing is the top part of the flat iron. The other hot one is the base. The casing is the top one. So that's such that when you touch the casing of a flat iron, you don't get electric shock because any stray current is connected to the earth, so that it is at zero potential. I get it. Because there could be some, you don't understand strands. You have never heard of this word? Hmm? Yeah? Yeah? Yeah. Now, you see these connecting wires can have strands. They are like loose connections that may connect and then conduct current. So those ones can cause electric shock in the casing of the appliance. So what we normally do, we earth the casing of the appliance so that any stray current is directly connected to the earth, so that the casing is at zero potential and therefore cannot cause electric shock. And then there is 4, main switch. This switches off all the main current entering the house. And you will normally do it during electrical installation, such that if there is any problem, you can simply switch off the main switch. I remember when we were still young, there were kids who were playing with these sockets and then just fixed there a finger. So the only way of saving was run very fast and switch off the main what? The main switch. Okay, how the earth connection prevents electric shock. We said the earth wire connects the metal casing of the appliance to the ground. If the insulation of the live wire wears out, such that strands of the live wire come in contact with the metal casing of the appliance, the earth wire will carry away the current to the earth. It carries away the current to the earth, so that does not cause electric shock. Now we go to electric wiring. Electric wiring. Okay. You seem not to be following what we are doing. Or you are scared about electrical wiring. No, we are not going to begin with something big. We are going to begin with general connections. So there are two ways of connecting wires during house wiring. Are you getting it? We can decide to connect the wires in series connections. We can connect in series. So series means connecting end to end. So for example, if this is a bulb, we connect it in line with another bulb, in line with another bulb, like that. So that the current here enters. If the bulb have a given resistance R, then as the current passes through bulb L, we call this one bulb L1, lamp L1, lamp L2, lamp L3, there is a PD that is developed across the lamp. I'll call that one V1. Why? V is going to be called IR. So as the current enters the bulb of resistance R, there is a PD V1 developed. Same applies to V2, which I can call VL, and that one is called it V3 or V3 or V2. That matter. So meaning that when you connect the lamps or bulbs in series, each of the lamp develops its own PD. Are you getting it? Because different lamps have different resistances. So this is going to create the PD IR1, V2 IR2, and V3 IR3. It is the difference in the resistances that cause differences in the PD. But if the lamps are identical, the lamps are what? Then they will light with the same level of brightness because they have the same current and same resistance. Therefore, the PD V1 equal to V2 equal to V3. That one is possible. Is that one okay? So therefore, when you connect it in series, the current through the components is the same, but each component or appliance will have its own PD, depending on its resistance. Is that one okay? Now, what is the disadvantage about this nature of connection? The disadvantage is one, that if one of the appliances is faulty or gets a problem, the rest of the appliances will not work. Because current flows through this one to the next and to the next. Once this one is faulty or its fuse blows, then all the lights will be off. Are you getting me? That is the first and most dangerous disadvantage. The second disadvantage is that one bulb may consume large amount of PD. So that means in case there is little current, one bulb can light and the rest will not be getting anything to use. Because the total PD is the sum of the individual PDs. Now, something to note. In electrical wiring, all appliances connected in series use the same switch and same fuse. This one use the same switch and the same fuse because they have the same current going through all of them. Is that advantage or disadvantage? Disadvantage, advantage. Yeah. One switch is advantage. Now what if there are different rooms? And someone switches off when another one in the next room wants to use the light. It may turn out an advantage in terms of economics, but in terms of flexibility and use, it is a disadvantage. Now we go to parallel arrangement, parallel connection. Parallel connection. Parallel connection. In parallel connection, we get two wires. We get the live wire and the neutral wire. And both of them are from the source. So we get different fuses. That is fuse 1, fuse 2, and fuse 3. Now, this one is the one that is carrying current, we call it the live wire. And then, this is the neutral wire. Now, the wire of the live wire does not come in contact with the neutral wire. That's why we do it like this, meaning that passing on top. That one shows that it's passing on what? On top. And this one has its own switch, and then goes to the first bulb. Then the current from the bulb goes to the neutral wire to complete the circuit. This is switch K1. Same applies to the second one. Even this one does not come in contact with the neutral wire. Goes switch K2, bulb, second bulb, then back to the neutral wire. Same applies to this one. Goes to the switch, the bulb, and then the neutral wire. So you can have lamp L1, lamp L2, lamp L3. Now, when you connect them, these are just fuses. Fuse 1, fuse 2, and then fuse 3. Are you noting that? So what we are saying is that each bulb has its own fuse. Are you getting it? That means if this fuse is of 1 ampere, and this one could be the different wires could be of different amounts of current, because depending on where we want to use. So this such type of arrangement is what we call parallel form of arrangement. Now, how advantageous is parallel connection over series connection? We said 1. If one appliance is faulty or switched off, the other appliances will remain unaffected. Like for example, are you seeing this? If for example this fuse blows, are you getting it? Current will come, ignores this path but continues, and then flows like here. And this one lights. Are you getting it? Even if this one blows, current will ignore this path and continue, and then flows here. When you close the switch here, this bulb L3 lights. So, if one appliance is faulty, the other appliances will remain unaffected and work normally. 2. Different currents can flow through each component. Now you can allow different currents to flow. For example, you may need the bulb in a bedroom to be producing low voltage. So you can adjust and ensure that you put there a low voltage, low current fuse that can be able to use less current. Then the third one, all appliances will be from the same PD, even if they have different resistances, because they have a common point here. All of them are having a common point there. That means the potential supply is the same for all the fuses. Unlike in series, where each bulb is having independent PD, all of them are supplying the same amount of PD. Therefore, the light, even if we reduce the amount of current, they will share the little that is available. You may find the whole school dim because it is connected in what? If it is that little will be shared throughout. Whereas if it was in parallel in series connection, the one at the main gate will be the only one lighting, the rest will be dim. Then there is no overloading. In other words, there is no way current can go beyond the normal. Then 3, a short circuit in one appliance does not affect the other appliances. So that is the advantage of parallel to series connection. Now I have a small note here. Actually, there are 3 notes. 1. In electrical wiring, each appliance connected in parallel has its own switch and fuse. We say the switch and fuse are always connected to the live wire. You may be asked, why is the fuse and switch connected to the live wire? Why is the switch and the fuse are always connected to the what? To the live, because the live wire is the one that carries current. The neutral wire is already at the server station so that it is at 0 potential. So if it is the one carrying current, and therefore it can melt when the current exceeds a safe what? A safe value, and therefore protect the appliance from damage. So 2, fuse rating. Fuse rating. Fuse rating. Fuses are rated at, you may have a 2 ampere fuse, 5 ampere fuse, a 13 ampere fuse, a 15, a 30, a 50, depending. I get on the appliance that you want to use. If you want to use a flat iron, then we get a socket. You make a socket that has a fuse of a relationship to the appliance that you're putting there. And usually they are whole number values. The whole number what? And the rating of the appliance should be slightly higher than the current flowing. Have you noted that, my dear? Can you look this side? I have a look. I'm saying the rating of the fuse should always be slightly higher than the current passing through the appliance. For example, if the power rating of an appliance 2000 rated, if the power rating is given by 2000 watts, 240 volts. And then the question is, determine the amount of the most suitable fuse for use. The most suitable what? What you do, find current. So the current I is power over voltage, because P is IV. So this is now going to be equal to 2000 divided by 240. What does that one give? 2000 divided by 240. What does it give? I think it gives 8.33. I don't know, you can confirm the answer. True. Hence, the most suitable fuse. Hence, most suitable fuse. How do you pronounce this word? Like this. Okay? Good. It is so. The most suitable fuse is what? Is 10 amperes. The most suitable fuse what? We look out for a whole number that's slightly greater. Greater than 8.33. Because usually make 5, 10, 15, 20 of that sort. So therefore we look out for a whole number value that is slightly greater than the current supplied in that certain appliance. 3. Short circuit. Short circuit. Now generally, short circuit is the path of least resistance or path of low resistance. But it can come in many ways. Like for example, if you have a battery of this kind, of course, within a battery, we have plates. And electrolytes. So this could be a positive terminal, and this could be a negative what? Terminal. Usually, it conducts, the current is conducted through electrolytes. You get me? But if you get a wire, and then you connect directly from the positive terminal to the negative terminal, the current will cease to go through because you have created a shorter path, negative, of low resistance. Current will simply pass from positive terminal to the negative terminal. And it has used a path of low resistance. Now this path of low resistance therefore provides large amount of current passing through because there is no resistance. And therefore there is great power loss in form of I squared R, causing a heating effect. So that's why you normally see sparks when you connect directly. So you see sparks, meaning that you are creating large amount of what? Current is the one that causes a heating effect. So that one is called short circuiting. The direct connection from positive to negative, creating a path of low resistance, is what we call short circuit. But short circuit could also occur when there is a connection between the live wire and the neutral wire. Usually the neutral wire takes back current. But if, for example, from here you connect a live wire connected to a neutral wire, you have created a path of low resistance. In other words, you are connecting positive to negative terminal directly. Because the live wire is the one that is carrying current. The neutral wire is connected to the negative terminal. The live wire is connected to the positive terminal. The neutral wire is connected to the negative terminal. So if you connect a live wire with a neutral wire, you are directly connecting from here up to there without passing through the fuse and other appliances. Otherwise, the normal path for current would be from here, passing through the fuse, passing through the lamps and bulbs, then back to the source. Now we are bypassing all these paths and then making a short path of low resistance. And that one carries large amounts of current that makes it spark. So someone could also define short circuit as the direct connection from positive to negative what? Terminal of the cell, or direct connection from the live wire to the neutral wire, because it's the same thing, or creating a path of low resistance. Oh, I don't know whether that one has been understood. Alright, now we have an activity. This activity we left it the other time. Do you recall? Yes, you are the only one I have. What? So now, all the questions are coming to you. So the first question, question 1a, is saying, explain why the fuse is always fitted to the live wire in any electrical appliance. In any electrical appliance. What is the probable answer?
Bricks and complete circuit.
Pardon?
Bricks and complete circuit.
It breaks and completes the circuit. Well, that is even a switch can do. To break and complete the circuit, that is the role of a switch. For example, I can close and complete the circuit. Isn't that one a switch? But I'm talking about a fuse. Why is it connected to the live wire? I've not even just answered it. I said, it is the live wire that carries current. It's the live wire that carries what? Current. So in case it exceeds its rated value, the rated value could be if it is rated 5 ampere, and then the current that is coming is more than 5 what? Ampere. So what the fuse does is to disconnect the circuit. It only disconnects, the difference with the switch is that this one only disconnects when there is excessive current flow. Are you getting it? It disconnects the circuit and protects the appliance against the risk of fires caused by heat. Are you getting it? So it only happens when there is excessive what? Current flow. And what it does, it just blows, because it is of low melting point. So if it exceeds the value set, it just what? Blows. Then part B, we are required to find the rating, the most suitable fuse. We are given 3 fuses. 3 ampere fuse, 5 ampere fuse, and 10 ampere fuse. And the question is, which fuse is most suitable to be used? Remember, the power was given to be 25 watts. And the voltage was given as 240 volts. So, now the question is to find the most suitable fuse. Let's find the current. Current I is power over voltage. That is 25 divided by 240. What answer do you get?
0.0.10.
0.1. 1041
41 and 666.
You call it 42 amperes. So according to the fuses that we are given 3 ampere fuse, 5 ampere fuse, and 10 ampere fuse. Which one is most suitable? It is 3 ampere. So the most The right answer, the most suitable fuse, the most suitable fuse is the 3 ampere. The 3 ampere fuse is the most suitable. That's number 1. Number 2, we are given a circuit of this nature. Are you looking at the circuit? Now, the circuit was arranged like this. You have the switch, okay, and then we have bulb. This was B3, and this one is this is so this is now going to be B1, B2. So, figure 1 is a circuit diagram set up made by some students. Part A, which bulb will light brightest when K1 is closed? Which bulb will light brightest when K1 is closed? Why B3?
Because in the current flows in these ones that are connected in parallel, they have to share the current, which means it's going to disperse.
Yes, they are going to share the current because the current supplied here is I, and all the supplied current goes through B3. And when it reaches here, the current is going to be shared. Are you getting it? The current is going to be what? Shared depending on the resistances of each of these what? Bulbs. So therefore B3 is going to be what? B3 will light brightest because all the supplied current flows through it. Then part B, if B1 blows, if B1 what? Blows, what will happen to the other bulbs? Look at the diagram. B1 blows. What will happen to the rest of the bulbs?
They will continue.
Huh?
They will continue.
Yes. The other bulbs will both light. Will both what? Light. But the brightness of the bulb will depend on the resistance of each of the lamps. Are you getting it? If B3 and B2 have identical resistance, are you getting it? Then they light with the same level of brightness. But if the resistance of B3 is less than the resistance of what? B2, then B3 is going to be lighting brighter than B2. When the resistance is high, current is low. Are you getting it? But if they are identical, they will light with the same level of what? The brightness. So anyway, the major important thing is that the rest will light. Whether they light with different levels of brightness, that one is not an issue in as far as the question is concerned. But if they are identical, then they light with the same level of brightness. Then part C, if B3 blows, what happened to the other bulbs? If B3 blows, what happened to the other bulbs? They will not light, because B3 is in series with the remainder. So once this one blows, don't ask me what will happen to the rest of the bulbs. Then we go to the last question. State the use of the following in wiring a building: the fuse, the switch, the earth connection. What is the role of a fuse? What is the role of a fuse? It blows to disconnect the circuit in case the current in the live wire exceeds a safe value. That's the major role. It is what? It is what?
The definition, I think that's the definition of fuse is a metal research.
Yeah, you can give a fuse, but you see, the question is role. What does it do? Eh? But when they tell you to define, you say protective resistor that does this and that. You are describing the fuse. But this time around, we only want the function. Are you getting it? So you don't need to tell us what it does, its structure. Are you getting it? This one blows to disconnect the circuit in case the current in the live wire exceeds what? A safe value. We use a safe value or a rated value. The value that is indicated on it, or the value that is safe for it to work. Then Roman 3, Roman 2, the switch. What did you say? Switch, what does the switch do? This one.
Breaks and completes the circuit.
Yeah?
Breaks and completes
Yes. Just breaks and complete what?
the circuit.
Or completes or disconnects the circuit. Then the earth connection. What is the role of earth connection?
It prevents electric shock by connecting the electric.
Yes, by conducting away leaking charge. By conducting away leaking charge. The current is connected to the earth. So any leaking charge when the strands connect from the live wire to the neutral wire, because electric shock can be prevented. Then, what is the role of the inert gas? The inert gas in the operation of the filament lamp. What is the role of the inert gas? Yes, what is the role of the inert gas? To prevent evaporation of tungsten. Prevent evaporation of what? Tungsten. Tungsten is the coiled wire within the bulb. And in so doing, it increases its operating temperature. Otherwise, if we don't do that, the tungsten will condense and then blacken the bulb. There is going to be a black thing that is within the bulb, so it will not give out the light. Lastly, you are given what? Huh?
I feel switched bulbs.
You are given what?
I feel I switch two bulbs and connecting wires. By means of a circuit diagram, show how a circuit can be arranged in order to have maximum brightness.
Yes. When do we have maximum brightness? In series connection, in parallel connection?
In series.
In series. So. For me, I thought in parallel. Because if this is the supply, and then you connect bulb 1, another bulb 2, another bulb what? 3. Even if the bulbs have different resistance, they'll have a common PD. Or the supply voltage is being used by all the bulbs. I get it. If you connect in series, what will happen if this is the total PD? This one consumes part of the PD, this one consumes part of the PD, and that one consumes part of the PD. So you realize if this one has low resistance, this is going to be brighter, this one less bright, the other one mean, almost dimming. Are you getting it? Whereas this one, they are connected to the same source, all of them. And if they are connected to the same source, they all light brightest, with the same level of brightness. So, in as far as the question was concerned, I think the arrangement was meant to be like this. Just the switch, can connect here the switch. We are given
a cell, switch, and 2 bulbs.
there are 2 bulbs. So I'll remove 1 bulb. So the required arrangement is that. I think the question was hard. Only that. Bulbs B1, B2, and then the switch, this is the cell. So what's that?
Switch is good.
Pardon?
Switch is good.
Yes. How will it now give brightness when it is open? And what?
2 release the shell before and after.
Before and after, but the question was saying after. It's because we are saying maximum what? Brightness. So that means our switch must be closed to give maximum brightness. Then explain how the earth connection prevents electric shock. That's what we did the other time. We said that the earth wire connects the metal casing of an appliance to the ground. If the insulation of the live wire wears out such that the strands of the live wire come in contact with the metal casing of the appliance, the earth wire will carry away the current to the earth. That's what we say. And that's how the earth wire works. Now, what we want to have today, and the conclusion of the study, is house circuit wiring. House what? Circuit wiring. How do they wire building? Here we are going to give you elementary. May not give you full detail. We're giving you what? Elementary. Look at the diagram. You are going to see we have a supply cable. We call it solido. The solido is usually connected to the meter box. But to connect to the meter box, we put the fuse, which we call the main fuse. But that was an old technology. It was an old what? Technology. You see, what Umeme used to do, they bring their fuse, fix it in the meter. Are you getting it? So once you have used up all your power, you have failed to pay, they simply come and collect the what? Fuse, and then you remain with no power. But people have become clever. So what they used to do, they simply get another wire and connect another fuse, and the thing could work. Are you getting it? Now, they invented what? A new form, yaka. And they made sure that yaka is not passing through the meter box. It is put on top of the tree to see how we are going to move top there and then change the what? The main fuse. So the main fuse is automatically made connected to how can I phrase it? It is made in such a way that when you pay, it closes. When you were not paid, then it switches off after your amount of money has been used up. So it is now an automatic main switch that depends on what? On technology. Now, what we are saying, when you look at the diagram there, the main fuse and the meter are now connected on top of the pole. Now the solenoid now comes next, comes after. They have converted the current. And then as it enters the building, then it reaches what we call consumer unit. Consumer what? Consumer unit. I don't know whether you have ever seen where either you normally put it in the sitting room, they put it at the top, where we have something of this nature. Where I have, they're like switches for the here, by the way, as the wire is coming with two wires is fixed inside. Usually a thick wire, but it's having two main wires. One wire is the live wire, and another wire is what? Is the neutral wire. Now usually this one is I have the neutral wire and the live wire. Now I'm now getting this one from the main fuse, meter box, and so on. So this one is neutral wire, and this one is the live wire. Now what we do, we attach different fuses. So if this is now the neutral wire, for the neutral wire, and then we get another one, we get the fuse connected to the live wire here, and then we connect it to the neutral wire of the appliance. So if there is this now live wire, if for example you have decided to put a bulb here, there are two wires coming into the bulb, the neutral wire and the live wire. Once you combine them, the bulb lights. We normally put a switch there. So in our consumer unit, this is our consumer unit, we arrange different switches for different usages, and each different switch is having a different fuse. So we normally have 3 ampere fuse, 5 ampere fuse, 15 ampere fuse, and 30 ampere fuses. Are you getting it? Usually there are 230 ampere fuses. The common ones are 5, 15, 30, 30. Are you getting it? Which you put here. Now, when you are wiring a house, there is what we call a ring main circuit. Ring main what? This one is where they put the sockets for ironing, for different sockets for the TV, those are usually 5. They connect a 5 ampere fuse from here, and usually here there is a switch here. There is a switch. It is usually open. If you don't want the children to use the sockets, are you getting it? You simply open that switch, thinking that they don't use the what? But the lights are on. The lights could be on, but the ring main fuse is not working. Are you getting it? And if you want to connect maybe to the flat iron heater, then you can connect. No, this one is usually for the lights because they use little current. Are you getting it? Then this one is for the ring main circuit. Ring circuit. Then this one is for heater, cooker, and so on. The control area is the consumer unit for the different switches here and different fuses. Are you getting it? So depending. Some people go to the extent that even different rooms have different switch within the consumer unit. So you may decide that the other room will not receive light. So this is like a consumer unit, like a control room. You can say now the whole block there is not going to have light. So you just switch on here. The whole block, even if they have their own fuses, switches, they will not all work. You have cut it off from this side. Are you getting it? So that's why we are having, we are saying the supply, electricity enters the house through the supply cable from the power. The supply cable consists of two insulated wires, the live wire and the neutral wire. The neutral wire is acts at the local substation and therefore zero potential, so the neutral wire does not cause electric shock. Then, while the live wire is at a high potential of 240 volts, the live wire is either red or brown in color. We attach it red or brown color, while the neutral wire is usually black or blue. So the live wire delivers current from the local substation or power supply to the respective appliances. The neutral wire carries back to the supply, thus completing the circuit. Then we said all switches and fuses are connected to the live wire, the explanation we gave. Then we got the consumer unit, the main fuse. Main fuse and meter. Each of the two wires, that is drive and neutral, are connected to the meter through the fuse in the meter box. So if a thick wire is connected from the meter to the earth, and therefore at zero potential, it protects the meter and the house against damage in case of overloading. You do it during earthing. Then consumer unit, we come here. Consumer unit. Now from the wire from the meter, the cable from the meter, are passed to the consumer unit, which consists of the main switch to switch off all the current in the house. The main switch is a double pole switch. This is the main switch according to the diagram. Switches off all the mains current. And the consumer unit also consists of a single pole fuse for each of the following. The lighting circuit is connected to a 5 amperes fuse. The immersion heater, 15 ampere fuse. The ring main circuit, 30 ampere fuse, because you are going to use it for ironing, cooking, so it requires a large amount of current, so we put the larger fuse. That one okay. Now in every circuit, they are connected in parallel. Connect them in parallel. So we are saying in wiring, the lighting circuit uses only 2 wires, while the heater and cooker uses 3. That is the live wire, the neutral wire, and the earthing wire. The earthing prevents electric shock. Then the ring main circuit. The ring main circuit. We said this is a circuit which runs in complete rings around the house. It provides parallel circuit connection to each of the electrical appliances that are plugged into the socket. So the current drawn from the power supply are large. The ring main circuit incorporates the earth connection and the 5 ampere fuse. So that's why you are saying we provide from the consumer unit, we connect the wiring for the ring main circuit, for the sockets which they are going to use. And usually the sockets are made of 3 pins, as you are going to see. That one takes to what we call a 3-pin, wiring a 3-pin plug. The plug we are talking about has 3 holes. That is the socket. The socket has 3. And therefore, the plug we are plugging in the socket should also have 3 pins. It has 3 pins. That's why we call it a 3-pin what? Plug. And there is little here to talk about. We said the 3-pin plug has 3 wires: the neutral wire, the earth wire, and the live what? Wire. We are saying the earth wire from the 3-pin plug is connected to the casing of the appliance, so that in event of short circuit, the person handling the photo plug does not get electric shock. The fuse is connected to the live what? Wire. Meaning that you can have only 2 wires. You can have only what? 2 wires for your appliance to work. As long as you have a neutral wire and the live wire, the thing can work. That one okay. Now we are concluding by talking about safety precautions during house wiring. Safety precautions during house wiring. What should we pay greater attention to during what? House wiring. We said 1, electric cable must be properly insulated. Okay. Sometime back, I asked the question, what is the purpose of insulation in the house wiring? What is the purpose of insulation? To prevent electric shock, because these are insulators, so they cannot transfer the current onto your hands. 2, keeps hand dry whenever dealing with electrical supply. Keep the hands what? Dry. 3, never try to repair electric appliance unless you are trained. You're going to say, now, for us, you can't. You can try, because if you are trained, you don't know whether you are holding a conductor and insulate. Are you getting me? So the screw you are using, you may touch the iron part of it. Sometimes the extreme end here is iron part, and this is the plastic part. So in not knowing, you may just put your hand like this. Then this one, the current passes through the iron part. So that's why we are saying it needs some little knowledge about electric supplies. Then never try to repair electric machines unless that's agreed. Fix sockets at heights beyond reach of children. These crawling children. You ensure that you put it what? Slightly higher. But these days, they are not putting them higher. They are putting them lower, but ensuring that the hole or the socket holes are of small diameter, such that even a younger kid cannot fix the tip of the finger inside it. Because raising it high would inconvenience the use. Am I getting it? So instead of putting it at heights beyond reach of children, just make the diameter of the sockets very thin, small, narrow, such that someone may not what. But still, putting it at heights beyond reach of children is also important, because someone may just get 2 wires and then fix one wire this side, another wire this side, and then hold. Are you getting it? And once someone holds like that, then problems can come. I was telling you, when we are still young, those days they were making sockets of bigger holes. So the child just did like this. And then we just started seeing the child vomiting serious things. And we were going to hold the children because there was one child who was helping to pull. Also, the connection went into her. So there were only two people. So by the time the elder people came, they said, don't go near them, don't go near them. They went and then switched off the main one. But by the time they had done that one, these two are already dead. Are you getting it? So the issue of raising at heights beyond reach of children becomes very important. Then the next thing is that in case one gets a shock, switch off the main switch immediately. That's what they did. Then 4, electrical switches or sockets are not fixed in bathrooms during house wiring. We don't fix them in what? Bathroom, because we expect water to splash. But what do you fix a switch in the bathroom? To what? And that is the reason why even the domestic hot water supplies, the switches are fixed at the top for only mature people to use. Actually, there are no sockets there. The sockets are outside this side, the other one is only for switching on and off. We don't put them in what? Bathrooms. The next thing is all circuits are connected in parallel with the supply to ensure that the circuit operates at full voltage supply. Then switches and fuses are fitted with a live wire in order to ensure that no part of the circuit in the appliance remains live when the appliance is switched off. We are saying switches and fuses are fitted in the live wire in order to ensure that no part of the circuit in the appliance remains live when the appliance is what? Switched off. And lastly, all appliances with conducting parts must be earthed. Flat irons must be earthed. Kettles must be what? Must be earthed. All those ones with touchable appliances must be what? Must be earthed. In order to ensure that we don't cause electric shock. Now, we are concluding by only giving you the final activity. Final what? Activity. This activity has only 3 numbers. The first one is general, is for general current electricity. What is a volt? A lamp rated 240 volts, 60 watts. Explain what this one means. Use the diagram to show 3 identical cells, each of 1.5 volts. The resistance 0.1 can be arranged to give maximum EMF. Calculate the current flowing in the circuit. If 2 resistors of 4 and 5 ohm are included in series, are connected in series in the circuit. Give any 2 sources of states. I think they said test sources, but you can give any 2 sources of EMF. Then carbon and manganese, with the aid of a double diagram, describe how an accumulator can be fully charged. Roman 3, carbon and manganese oxide mixed act as a depolarizer in a dry cell. Explain how this is achieved. Then question 2, we have sketch current versus PD variation for a metal wire. For a metal wire, just means an only conduct. And then a semiconductor diode. Then part B, figure shows a cell of negligible internal resistance connected to a system of resistance. Calculate Roman 1 EMF of the cell, Roman 2 current flowing through a 3 ohm resistor, Roman 3 power dissipation with a 3 ohm resistor. Part C, give NF4 difference between a nickel ion cell and the lead acid cell. Lead acid is these common batteries. Lastly, number 3, define a kilowatt hour. Define a kilowatt hour. Part B, an immersion heater rated 3000 watts is used continuously for 45 minutes, 4 times a day. Culture, the cost per week at Uganda shilling 100 per unit. I think that one was underrated because there is no unit of Uganda costing 100. Then part C, a cell in cells with 2 ohm and switch has a high resistance voltmeter across it. The voltmeter reads 1.5 volts with K open and 1.2 volts with K closed. What is the value of the EMF in the cell? What is the current through the 2 ohm resistor? What current would flow if the cells were short-circuited? Short-circuited means connecting the positive and negative terminal directly, or ensuring that K is open. When K is open, it is already, and the wire is connected from positive terminal to negative, that is short circuit. And lastly, what would the voltmeter read if the cells were short circuited? And last number 4, is about house wiring. Look at number 4, it's about house wiring. Give 2 advantages of parallel connection of appliances during house wiring. 3, figure 3 shows 3 identical bulbs. When switch K is closed, bulb B1 shines brighter, but B2 is dimmer. Explain why this is so. You'll use that diagram to answer that question. Part C, figure shows the circuit mostly used in house wiring. In house wiring, there are no calculations, just explanations of how things are done. State which bulbs will light when switch K1, K2, and K3 are all open. Roman 2, about to conclude. Roman 2, switch K1, K2 are open while K3 closed. Roman 4, switch K1 open, K2 and K3 closed. So in each of the cases, you tell us which bulb will light. The question does not require explanation. You just tell us which one will light, because the explanation will depend on the flow of current. I thank you so much, yet again, for being resilient, patient, and persistent from the beginning of the topic to the conclusion of the topic. I thank you so much. Wait now for the assessments, which are going to come soon next week. Please read the whole electrostatics and the whole current electricity, because all questions are going to rotate around there. I wish you the best of the day.
They have exams next
Assalamu
week.
alaikum wa rahmatullahi wa barakatuh.
They prepare for exams next week.
Prepare for those exams, inshallah, 1.5 hours.